Uh, Hello, everybody, and welcome to today's session on derivatives. So, my name is Amandeep. I'm leading academics here at TutorI, which is a leading tutoring solution across US, Canada, and Middle East. We are 24/7 e-learning platform helping students achieve their academic goals through expert online tutoring and written services. With us joining today as a guest speaker is Ms. Keva Lockhart. So Keva is from Bahamas. She has done bachelor's in science and biology from St. Hugh University and is also a trained teacher in one of the government schools in Bahamas. She teaches senior school biology and health sciences. Thank you so much, Keva, for joining us today. How are you?
I'm fine, thanks. How are you?
All good, all good. So can you share about your experience in teaching biology in Bahamas? How was it like?
Okay, so good day, everyone. Again, my name is Gaba Lockhart. I'm from the Bahamas, and I'm also a tutor on TutorI, where I teach biology and English. Now, my experience in teaching biology and health sciences in the Bahamas has been a great one. I've always loved teaching science, so going into the field of teaching was something that I was passionate about. And
Okay.
also, when we look at science, I know when I was in college, there were a lot of people who were afraid, they shunned away from sciences. And I was glad to be one of the few at my school who actually just took science on and was ready to go full time in science and also teach student science because when you look at it, we're in a whole pandemic, and science is very important for us to know during this whole pandemic. So, science is something that we all should be involved in. And when you look at it, science is all around us every day. There's something to deal with science. So, that's what I teach my students all the time. I try to make my lessons in such a way where my students can correlate science along with what's going on in the world so that they can have that connection, not just
Awesome.
book work, but that they can have some connection.
That's wonderful. So, Keva, we'll probably get back to you on maybe learning strategies that you use in your classrooms. Uh,
Okay.
right. Thank you so much. We also have Manish with us, who's our in-house tutor for math and is passionate about teaching and tutoring complex topics. We're also delighted to have Sebastian Edgar, our in-house tutor and guide who will take us through this tricky topic called derivatives. Sebastian, welcome to our free learning session, everybody. Sebastian is joining us today from Switzerland. So if anybody needs any chocolates, please contact him. Sebastian, how are you?
I'm actually doing really well, thank you very much. How's it going?
All good, all good. How's the weather there in Switzerland?
Oh, it's been beautiful actually. We've been blessed with a really nice summer, so we've been soaking it in. But I think we're kind of moving towards autumn now, so I'm not so happy about that.
Okay, wonderful. So again, I would really like to thank our guest speakers, Keva, tutors, Manish, Sebastian, once again for joining the free group class on derivatives. I would like to kick off the session with my first question to you, Keva. Since you're also a tutor, how do you see tutoring education in general post pandemic? Is it going to stay online, or we have to adapt to hybrid models? What's your take on that? Keva, you're muted.
Sorry. Okay, so I think that tutoring online is here to stay. I think that it's a good avenue for students, especially if you're in one part of the world and a good tutor is in one part of the world from the student. So I think having online tutor is here to stay because there's a lot of things that you can do online with tutoring. So you can
Right.
be able to assist students, and it's an all day thing. So once the tutor's schedule is cleared and so forth, they'll be able to effectively help that student. And sometimes the students don't get the help that they need from in class. So having a tutor that they could connect with online and a reliable tutor, it will allow them to keep coming back and so forth. So I think it's here to stay post pandemic.
Right, right, right. So that's an interesting thought. Um, you know, For all the viewers who are joining us right now, a recorded version of this webinar highlights will be sent to your email ID also. Keva, again back to you. In your opinion, in terms of say instructional strategies, how much it varies from schools to colleges? If you can throw some light on that, please.
Okay, so what I've noticed about schools, based on high schools to college, there are many different strategies that you use from high school to students, because what I've realized is that the same strategies that you use in high school, you can't use in college, because college is where you get more concrete information on what you want to study. There are some things that you could get away with in high school, but in college you can't do that. So there are the different strategies. You have to be more concrete, you have to be more reliable, you have to be more efficient, and the students have to be more efficient in what they do and how they study.
Right.
Strategies that they used in high school possibly can still work, but when we talk about strategies for college, it has to be concrete and something that they could take throughout their lives, because when you're in college, you have to consistently keep studying and studying because you're now in your major field. So I think that there's different strategies there for high school and college.
Okay. So that makes a lot of sense. Everybody, I would also like to share, will be opening for question answers once Sebastian has completed his session on derivatives. So please stay tuned. Sebastian, I have a question for you. When you tutor students, and I've come to understand that you have stayed in politically unstable and difficult places like Sri Lanka, Zimbabwe, and Kenya. Would you like to share your experience on how economics also became your preferred subject eventually?
Yeah, I think that's a great question, actually. I think for me, having lived in quite a variety of places, especially a lot of which were, as you mentioned, quite underprivileged, you begin to see that economics is really something that plays a big role in the lives of everyday people. Even if you don't necessarily have a great understanding of economics as a field, it's something that impacts you, me, and everyone around us. So I think the more I started to understand economics, the more I actually started to understand the world around me. So that's kind of where my enthusiasm came from, and that's part of the reason why I would actually say that be it just a small interest or actually something you want to go and study maybe at university or beyond, I would definitely recommend everyone familiarizes themselves with some of the key principles and theories within economics.
Sure. Thank you for sharing that. Before we jump into Sebastian's session on derivatives, Keva, can you also throw some light on a challenge that when you see a lot of students needing academic support, but no one is there in that moment of frustration, what can be a way out? Do you see Tutorai can help us there? Do you see some synergies building there?
Sorry, can you repeat?
Okay, so my question is, when you see a lot of students needing academic support or help from a tutor, from a teacher, and no one is there, in that moment of frustration, do you see a way out? Can Tutorai help us there?
Okay, so in the moment of frustration, students tend to look a whole lot of places, especially different tutor sites. So, which is why tutors need to be reliable. I believe that we should be reliable, like always there to help them, because I understand frustration when it comes to you have an assignment and you don't know what to do, you need specific help. So I believe that having an open schedule for tutors will allow them to connect with students, or even having prior schedules. So for example, if a student knows that they have a particular project that's coming up, they can say it in advance to the tutor, and the tutor, which should be reliable, should be able to help that student in order for them to be able to get the work out, so that it eliminates frustration for that student.
Okay, great. Lastly, for those of you who have joined us now, welcome to a free session on derivatives. With me is Keva Lockhart. Keva is from Bahamas. She has done Bachelor's in Sciences and Biology from St. Louis University and is also a trained teacher. Sebastian, I would like you to start your presentation, and everybody please stay tuned and keep posting your question in the chat box. We will try to pick them up and ask Sebastian to answer some of them. And over to you, Sebastian.
Great, thank you very much. Awesome. I'm just gonna pop on the screen share and open up the PowerPoint. Is that visible? Everyone can see that?
Yes.
Great, awesome. Okay, so derivatives. Derivatives is really the first thing, the first step in calculus. And I know a lot of the time, calculus might sound scary. You might have heard maybe your older siblings talking about it as a really hard topic. But actually, I think you'll find, at least with introducing derivatives, it's quite straightforward. It can even be quite fun. If you just learn the process and you do some practice, it becomes nice and straightforward. Okay, so first thing you guys are probably wondering is what actually is a derivative. So here we've got a nice definition, and it's saying it's the varying rate of change of a function with respect to an independent variable. So when we think independent variable, we're usually thinking about an x-axis and a y-axis, and input and outputs. So whenever you hear the word derivative or differentiation, the first thing I want you to think about is slope. It's all about the slope. So as I'm sure you're familiar with, you have functions, and there's different types of functions. You might have a linear function, a quadratic function, and all of these have different slopes. Now, in the box here, you see a linear function, and with a linear function, the slope is consistent throughout. Here, it's not, I can't quite see what it is. I think maybe it's, looks like a relatively steep slope, but that slope is going to be consistent throughout the line. Once you get into functions that are a little bit more complicated, for example, you increase the exponent to 2, 3, so you have your quadratic or cubic functions. What you'll notice is that the slope is different at different points on the line. So the whole point of a derivative is to take your original function and convert it into a function which will tell you what the slope of that original function was at any given input of x. So this process of going from a function to a derivative is called differentiation. So like I said, whenever you hear derivative, think slope or gradient, whatever works for you. So here's actually a example in real life, probably something most of you come across every single day. And it's actually the relationship between displacement, so your movement, velocity and acceleration. So let's say you're moving around, but now you want to know, okay, well, how fast am I going? Velocity is the rate at which your movement is happening. So it's how quickly are you going? At what rate is your position changing? So if you had a function for your movement and you did perform differentiation, you would find a derivative, and that derivative would represent your velocity. So great, now you've got your velocity, for example, right? You're driving in a car at 80 kilometers an hour. But then you start to increase your speed. Again, this is something that could be represented on a graph as a new slope, rather not a new slope, but a change in gradient along the original slope. And if you're increasing your speed, for example, it might become steeper. So acceleration is, so let me just move this out of the way here. Acceleration is the rate at which the velocity is changing. So then if you were to have a velocity function and you once again performed differentiation, and you found the derivative of your velocity, that would be acceleration. So again, like I said, all of this is basically to say that you have a function and you want to convert that into one which will tell you how your rate or your slope is going to be changing throughout it. Maybe this sounds confusing, but once you see that there's actually some pretty straightforward formulas to finding derivatives, you'll realize it's a lot simpler. So, all right, we're going to jump right into a problem. Here we go. So the question is, find the derivative of x squared plus 2x plus 3. Now, when you're differentiating, which again, remember, means finding the derivative, I think it's easier to break this up into 3 separate items. Here, sorry, let me just annotate. Here, you have a variable with an exponent that's greater than 1. Here, you have a variable with a coefficient, and here you have a constant. Basically, when you're differentiating, the rule is slightly different for each of these different parts of the equation, parts of the formula. So it's best to, when you're starting, to split them up, perform a slightly different function on each, and then you put them back together at the end. So first, we're going to just start in order with finding the derivative of x squared. So another important thing to notice, whenever you see this here, which says d, sometimes you'll see it written as dy over dx. Again, looks confusing. All it means is you're taking the derivative. So as I mentioned, when you, even though the question is asking us to take the derivative of the whole function, we're actually going to do it in 3 separate steps, and we're going to do each of these variables one at a time. So down here in the box, you'll see the general rule for whenever you have a variable with an exponent. It's called the power rule. So might look complicated. Again, it's actually pretty simple. All you do when you see a variable with an exponent is you take that exponent, you put it out in front as a coefficient, and then you reduce what the exponent originally was by an integer value of 1. That's it. So as you can see in this general example, we've got x to the power n. So you just take that n, you move it out in front. So which, as you can see here, it's now been moved out in front. And then you take that value of n and you subtract 1. So how would we do that in the case of x squared? Well, it's really quite straightforward. I'm just going to work off to the side here. You start with x squared, and we want to be finding the derivative. All we need to do is we need to take this 2, move it out in front. So let's start with that, 2x. And then we take what our original exponent was 2, and we reduce it by 1. So it's 2x to the power of 1. Sorry, 1. As we know, anything to the power of 1 can just be written without the power. So that just equals 2x. Awesome. So we've now found the first part of our derivative. We're going to keep moving through. Now we're going to go onto the 2x. So I need to just move my mouse so I can change slide here. And I'm going to erase this stuff. So actually, that was probably even the trickiest of the 3 parts of the formula. You're going to see that it gets even more straightforward now. Cool. So now we are we're differentiating this 2x. And what's slightly different here is you see that it has a coefficient, the coefficient being 2. Now remember, something very important to remember. Actually, we saw it just in the previous slide. Whenever something is written, any variable is written without any exponent, you can always assume that there's a little invisible, sorry, I'm having trouble writing that. It's got a little invisible exponent of 1. And you'll see why that's helpful to remember when we start this process. So just to make life a little bit easier, when you're differentiating any variable with a coefficient in front, for example, 2x, you want to just you want to isolate the variable by itself. So as you can see here, they've just separated the 2 from the x, but always remember, we're going to put that back. We're going to multiply it back at the end. So now, if we're just finding the derivative of x, well, actually, we're really doing the same thing as we did in the other step, remembering that it's got this little imaginary exponent of 1. So as we did before, imagine now we just have x to the power 1. remembering our power rule, first we take the exponent and we move it out in front. So that's going to give 1x. And then we subtract the exponent by 1. So 1 minus 1 equals 0. So what do we end up with? We end up with 1x to the power 0.
Sebastian,
Now,
Sebastian, sorry
Yes.
to interrupt you. Your slide,
No
the
worries.
PPT, the screen which you're displaying is minimized. The slide which you're representing. I think so. Yeah,
Sorry
that's
about that.
Please maximize
On
that.
my, can you see it now?
No. I think so. Your visuals are quite, but the slide which you're presenting is minimized. Could you maximize that so that it can be presented on the screen?
Yeah. Sorry about that. Sorry. On my end,
Yeah.
it seems maximized.
Yeah, it's minimized actually.
No, I don't want to do that. If
Shiva,
I,
can you see that slide? Because I
Yeah.
can see it.
how about that? Is that any better?
Shiva, you're muted.
I can see it.
Okay, I can also see it. Sebastian, you can continue.
Okay, great. Sorry, so as we were saying, we have, sorry, I erased what we were doing, so let's just remember. So we separated the coefficient, so we put the 2 out in front. So imagine that 2 is there. Now we're working with the x by itself, remembering we're not getting rid of the 2 completely, we're just isolating it for a second. And whenever you see 2x, it means it's 2 times the x. That's why I'm using the brackets. So we have x, like I said, with the imaginary exponent of 1. So x to the power 1. So we move that 1 out in front and we subtract 1 from the original 1. So we have 0. So that's going to give us 2. Now remembering, if you have something written, if you have a coefficient of 1, there's no need to write the coefficient. 2x to the power 0. Here's an important rule, which I hope you've learned before. Any variable to the power 0 just equals 1. So this is just going to, so I'm just going to have to move my little bar down here. This is ultimately just going to equal 2 times by 1, which gives us 2. Great. So remembering from the previous slide, we had 2x. We've now found this is 2. So we're keeping the plus sign the same, plus 2. And now we're just finding the derivative of the constant, which was 3. And this is the easiest rule of them all. Whenever you're finding the derivative of a constant, it's always just going to be equal to 0. So here we can just say plus 0. And again, you don't need to have the plus 0. So what does that give us? Ultimately, our derivative, let me just redo that. Our derivative is equal to 2x, which comes from the x squared, plus 2, which comes from the 2x, and the constant of 3, we get rid of it. So that's going to be our final answer. And that's really it. So as you've seen, it's a couple different formulas which you're applying. Once you get the hang of it, do some practice, you realize it's a lot easier. There's one more concept which we're going to cover, but otherwise it's process of differentiation is really repeating these steps and getting familiar with it. Just going to move this to the top. Great. So how do, oh, I'm still drawing. I want to be drawing. Okay, so as you can see, here's our answer. We broke it up into 3 individual steps and we put it back together at the end to get our answer. Great, so now we're going to be doing the derivative of when you have, for example, sine of x or cosine of x. Again, this might seem like it's really confusing. You're seeing a lot of variables on the same page. It's really straightforward. In the box, we've got the rule here. Whenever you're finding the derivative of sine of x, it's just going to equal cosine of x. I'm going to actually jump forward just to let you know the other rule we're using. Whenever you're finding the derivative of cosine of x, it's just equal to negative sine x. That's it. That's the rule you've just got to remember. So once again, the question is, find the derivative of 2 sine x plus 3 cosine x. And once again, we're just going to do the same thing. We are going to see that this is kind of 2 separate things. We've got this one. We've got this one. We're going to work on them individually, and then we're going to put them back together at the end to find our derivative. So let's just start from left to right, 2 sine x. So as you can see here, down at the bottom, it's saying the derivative, as we did with the previous one, where it had a coefficient of 2. Once again, we just want to isolate the sine of x by itself and move this 2 for now. And we want to perform our rule. So as we can see in the box, derivative of sine of x is going to equal cosine of x. So here we have, so if you're performing the derivative, it's going to mean that 2 multiplied by the derivative of sine of x, as we've seen in the box here, is cosine of x, which can be simplified to 2 cosine of x. That's it, really simple. All you're doing is when you're doing the derivative of sine of x, you just change it to cosine of x, and you're keeping that coefficient the same. Great. So now we're going to go on to our 3 cosine of x. And you're going to note there's something to make sure you're aware of whenever you're working with negatives, is you've got to can't ignore them. So once again, 2 cosine of x. Remembering that the derivative, as we can see in the box on the right hand side, the derivative of cosine of x is just negative sine of x. So what we want to start by doing is actually it's written out really nicely down here at the bottom. You want to isolate the cosine of x and move the 3 over, because we're not differentiating the 3, just the cosine of x. You then perform the rule, which is that cosine of x, when you're taking the derivative, is sine of x. So you're going to get here 3 multiplied by negative sine of x, which is ultimately just going to equal negative 3 sine of x. So we had, if we go back to our original function, where we had 2 sine x plus 3 cos x, remembering that we found the derivative of 2 sine x to be 2 cos x, and the derivative of 3 cos x just to be negative 3 cos x. We want to put those together. So we've got our 2 cosine of x, and remembering it's a negative, so it's plus negative 3 sine x. Whenever there's a plus and a negative, you know that's just going to make a negative, giving us our answer here. So that's it. It's, like I said, it's really simple, and it relies on just a couple formulas, which you've just got to remember. And once you remember those, practice, 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 because that's how you're going to get good at it. You're going to develop an intuition for it. And ultimately, what does this mean? For example, if we go back to this, if we start with a function, remembering back to our introduction, if we start with a function x squared plus 2x plus 3, and we find a derivative 2x plus 2, what the derivative is telling us is that if I want to know what the gradient of this original function is at any point on the line, for example, at the point whereby x equals 2, all you got to do is use your derivative and plug it in. So for example, if I want to know what the gradient of this equation is that I just boxed when x equals to 2, what I would do is 2, put in my variable as I want it, 4 plus 2 equals 6. So we know at that point on the curve, you're going to have a gradient of positive 6. I believe we can discard those, and I can stop share. That's it for the PowerPoint. If anyone has any questions, I'd like to open the floor. I hope that was somewhat clear.
Okay, I believe not right now. But again, Sebastian, is there anything else you want to sort of share with us through that presentation?
Well, in terms of derivatives specifically,
Mhm.
like I said, derivatives and calculus, it seems like something that's really complicated. You might be scared of it. You see a lot of variables and it might seem confusing. It's really not that. All you're doing is you're taking functions, which I'm sure you're very familiar with, and you're converting it into another function that's going to tell you the gradient at any point. Those formulas, I really encourage you to practice using them, because you'll find that once you get the hang of it, it almost becomes fun. It's that easy. And yeah, that's it.
Awesome. So thank you so much, Sebastian, for some interesting insights into derivatives. It's a skill to make math interesting, I believe, and there's a reason that math phobia is a dictionary word. Yeah. So
Absolutely. And if anyone wants to study economics, calculus is a very important part of it, and therefore you got to know your derivatives too.
very true. So lastly, Keva, we would like to thank you, and also want to ask you if you can share your experience around tutoring, etc., and what do you think about tutoring in general?
Okay, so my experience for tutoring has been one of value. I'd say that it's always good to help students, especially because you find that sometimes there are some things that students are afraid of asking when they're in class because they don't want to get teased from their peers, or they don't want to make themselves look bad in front of their teachers. So that's where tutors come in, and tutors are there to be that teacher for those students and help to clarify anything that the students are having difficulties with. So I'd say that I had an awesome experience tutoring, being able to help students in science and English and writing, which is something that I really enjoy doing, and ensuring that at the end of the day, it's not because, okay, you tutor and then you receive payments. It's not because of that. It's tutoring because you want to make a difference in that student's life. You want them to go out there and you want them to be successful in their endeavors, and you want them to get a good grade, and you want them to pass, and you want to see them succeed like a teacher and a tutor should. So my experience was good, and I hope to see more students on TutorEye.
Excellent. So thank you so much, Keva, our guest speaker today, and Sebastian, our in-house tutor on derivatives. For all the parents and students, if you still have a question that needs answering, feel free to hop on to tutoreye.com, and we promise to help you find a solution to all your academic problems and assign an expert tutor that will in the first 3 minutes of you being there. On a closing note, Keva, thank you so much for graciously accepting to be our guest speaker. Would you like to share any closing remarks with us?
Yes, no problem at all. I'd like to say that online tutoring is definitely the way to go. And like I stressed, like I said, and I can't really stress it enough, that online tutors are here to help, and we're here to be reliable for those students, because some students, they're just afraid to ask questions when they're in class. So being able to help students, and we want to make them, as tutors, we want to make those students feel comfortable, and at the end of the day we want them to understand what they're having difficulties with, not just do work for them or give them tips or whatever. We want them to really understand so that they'll be able to do well and also help others.
Right. Awesome. Thank you, Keva. Sebastian, would you like to share anything before we close the session?
No, I think Keva actually summed it up pretty nicely. So yeah, I'll go with what she said.
Okay. So again, thank you so much, Keva, Sebastian, Anuradha, Manish. Amazing team. Thank you, team TutorEye. Thank you, everybody. Stay blessed, stay safe, and Godspeed. Thank you and take care. Bye-bye.
All right, all the best. Thanks, guys.
Okay.
All the best. Take care.